Oh, you didn't need it since you weren't in. You went in front of your. Yeah, we're going to go through those today in class to use the stuff we've learned so far. Yeah, 9. I did. That reminds me. Thank you for saying that, because I want to talk about something. So, if you go to the homework assignment page, you get to the bottom and you think, I thought I'd forgotten to put them in there, but there actually are enough homework assignments that you have to now go to page 2. So here's page 2. So you can see that all the stuff is on there now as far as all the dates are concerned. So today was 3.6, and then 9.1 is due Wednesday. I didn't have section 9 on there yet, but I did have 3.5 and 3.6. So, okay. That's it. Is Timber in class? I don't think she is. I haven't seen her pop up yet. No. Not yet. Or she's not here in class either. She's not online, and she's usually a few minutes late. So when Timber comes in, let me know, because remind me so I can let Mackenzie know. Now, for you guys online, I have a handout that I'm giving out in class, and we're going to go through some of that today. So if you don't have a printer to print it out, you can just follow along. And if you have any questions, you can look at it later. Or if you want to stop by my office and get a copy of it.
Throw it at me.
Yeah.
Justin said he was going to be a little bit late.
Who was that, Justin? Yeah, okay. So the first thing we're going to do is we're going to just finish up talking about circles. So last time we were saying we want to be able to define the different things associated with circles. So we were up to semicircle, I think. So this is the same drawing. The semicircle is, we don't have anything to show what a semicircle, any terminology, but the semicircle would be this curve that goes from R through Q to P and then back to R again. So a semicircle is a half circle. We have 2 more things that we want to identify, which are the tangent and the secant. So if you've taken pre-calculus, you've heard of tangent, secant, but they're completely different than what they are relative to a particular circle. So this is the same circle. So it's kind of interesting. This is a side note. There was somebody from the Richmond office to talk to us about Blackboard, what things we like about Blackboard, what things we don't like about Blackboard. And what's that? Yeah. So I had questions about Collaborate since I use that a lot. And I was talking about something, and the person said, yeah, there's usually one of you on campus, on each campus, which I think meant one person that uses a lot, which is kind of disappointing. I mean, on a campus our size, when it's so small, one person using it extensively is not surprising. But when you have big campuses and people aren't using it a lot, I'm not sure why you wouldn't use it, but it turns out I said, oh, you must know Rick Clark. He's an engineering professor at Virginia Western, because he uses it a lot. He does engineering classes where you can attend online synchronous, meaning at the same time. And I said, oh, you must know Rick Clark. Oh yeah, I know Rick Clark. So he must be the Virginia Western Community College Collaborate super user. So anyway, I felt special. Okay, so a tangent to a circle is a line which only touches the circle in one point. So on our diagram, we have one tangent line, and it's this one right here. So it's a line. So the tangent is the line RT, and we use a line symbol, which is an arrow on both sides. You could also say it's line TR. Again, lines don't matter what the order of the letters are. It doesn't have to be the point that it's tangent at. One interesting thing about tangent lines is they are perpendicular to the line that goes from the center to that point. So this angle would be 90 degrees right here. Okay, a secant is a line that goes between 2 points on the circle. So line PQ is a secant line. So we have PQ, it's a secant, it's a line. It could be also line QP, because the order doesn't matter. And also the line P comma R, and I'll just show it in one of its forms here. The line P comma R is also a secant line. It's a special secant line in that it's the line that goes through the center, but it's still a secant line, because a secant line only has to go through 2 points on the circle. A tangent line goes through 1 point on the circle. So if I were to draw another tangent line, just as an example, that would be a tangent line, and that would be a tangent line. So there are an infinite number of tangent lines on a circle. So here's problem 51 in your book, and so we're just going to go through these and see if you guys can identify them. So you guys in the class can help me out here. I'll do the first one. That's easy. O. Okay, the center is point O. So let's just start around the class. I'll remind you. Okay. Oh yes. There you go. So James, So is radii a line segment or a line? Line segment. And there should be 4 line segments that are radii. So what are they? Okay, so we have O. I'll just do an alphabetical order. So OA, OB, OC, and OD. So there are lines that go from the center to points on the circle, and they all have the same length, and they're line segments. Okay, Morgan. So the diameters are all the way through, yeah, and they're lines or line segments. So line segments are like this. Lines are like this. Line segments are like that. Yeah, so the ones that stop. So they're line segments, and there are 2 diameters. It doesn't matter, no. Yeah, so it's DB and AC. So those are the diameters. Okay, so oh, hold on a second here. I'm good at names without looking at. Hold on. I'm sorry. I'm embarrassed here. So, Harmony. I don't know why I had a brain. I should know your name. Okay, Harmony. So the chords. There are. I guess there are 4 chords. Do you see 4 chords? A chord is a line segment that goes from one point on the circle to another point on the circle. Yes. Yep, DB, AC, yep, BC, yes. Okay, that's correct. So two of them are the diameters, and two of them are these two line segments. Okay, Laramie. So the secants. Are those lines or line segments? Lines. Yeah, so it's the same as the two chords that we had, except they're lines instead of line segments. And that's not correct. So it's, well, I guess, yeah, according to the way they're showing it here, it's A, B, and B, C, or BA and CB, doesn't matter the order. And we have, let's see, one tangent line, so Harley. Yes, so it's EA or AE, it's a line. So it's this one because it intersects the circle, it touches the circle at one point. Okay, so that's good. Okay, so here's a rule about what are called inscribed angles. Inscribed angles are angles that are created by taking 2 points on a circle, P and R, and then taking a third point, Q, and drawing lines from Q to P and from Q to R. So let me put it on one page so we can see it a little bit better. Now, this angle X, this is what's called the intercepted arc. You can think of that more easily by drawing lines from the center of the circle to those points. So that's the center. Oops. It's like wiggling that thing. It's like a little dog with a tail. So this angle here is the intercepted arc. This is the inscribed angle. So this angle has a measure of X. So let's just, as an example, that looks about 80 degrees. This angle is slightly less than 90 degrees. So this angle is 80, and therefore the rule says that this intercepted angle, the inscribed angle, is half of the intercepted arc. So these 2 points are fixed, but I can vary point Q, and I can make other inscribed angles, or angles inscribed. So if I went from here to a point, another point on the circle, this angle would also be 40 degrees. And if I go to another point on this circle right here, the angle between there and there is also, this one's 40 degrees. So no matter where I put that intermediate point, point Q, the angle that point Q makes with the other 2 points is always the same. So if you've ever seen those, they're like crafts where you put nails around in a circle and then you connect them together and they give all these nice little patterns. Well, the reason it looks so regular in terms of the patterns is because these angles, if you have the nails equally placed around the circle, then they're all going to have the same same intercepted arc, and then you can connect them to any point around the circle, and those angles, these angles, this angle, this angle, that angle, they'll all be the same, and therefore it looks nice and gives you a fancy little shape. One specific kind is the case where P and R are right across from each other. So PR is the diameter, and then if you pick a point Q anywhere, because, well, the angle between R and P is 180 degrees. It's because we go halfway around the circle. Fully around the circle is 360 degrees, halfway is 180. So the inscribed angle is going to be half of 180 degrees, which is going to be 90 degrees. So if I take this picture and I just draw some just to prove it works, so I'm going to draw a, let me use blue. So if I take these 2 points and I draw anywhere to anywhere here, start there, go to there, that's a 90-degree angle. If I do the same thing again, so pick up all the way over here, that's also a 90-degree angle. So that's pretty cool as well. So we end up with all these right triangles. All the inscribed triangles inside this semicircle are all right triangles. And there's probably some way you can use this to prove the Pythagorean theorem, I would think. It looks like something that might work. And there's a homework for section 9-2, so that's due next, whatever day that is, Monday. So I'm actually going to, no, I don't want to do that. Sorry. I was going to actually put it in my list here while I'm thinking about it instead of forgetting about it later. So while you're copying those down, I'll enter my new task. So section 9.2 homework, Monday, Wednesday class, due the 31st. Submit. There we go. Good. I'll probably remember to do that about one time and then I'll forget it. Based on my past bad experience. What we're going to do now before we move on to the next section is we're going to look at this handout. So hopefully, I think I've got one where I can show you all of them separately. See if everybody's good. Check here. Chapter 9. Unknown angles. Worksheet. That looks like about the right thing. See if that works. Oh, let me save this first. No, that's not the one I was looking for. That's the second part. Let's see if I can find the first part. And how about this one? Ah, there we go. So these are the problems that are on your handout sheet. So the first problem, they're asking for what are the values for angles A, B, and C. The key thing is that this means that these two angles have the same value. So let's start what we know. If this is 112 degrees, let's see who we got next there. So Mary, what is the value for this angle? Yeah, let me put this on one page. So these are vertical angles. The vertical angles are equal. So that's 112 degrees. Okay. So if this angle is 112 degrees, then Jackson, oh, you need one of these. Yeah, come on, get it. So if this is 112 degrees, Jackson, what's this? Yeah, 112. Okay. Miranda. So if this is 112 degrees, and these are again two intersecting lines, so what is angle B? 112 degrees. Okay. So all we've used so far is that these two symbols mean these two angles are the same and vertical angles are the same. So now who's left here? Well, Justin got here. I'm not sure whether I should put him on the spot, but what? We'll skip over here. James. So what is angle A going to be equal to? Yep, 68 degrees. Okay, these two angles are supplementary. So this one's 68 degrees because 180 minus 112 is 68. And as a consequence, angle C is 68 by two reasons. One is because these are two vertical angles, and these are supplementary angles. So either way, you should be able to get all the answers. So A is equal to 68 degrees, B is 112 degrees, C is equal to 68 degrees. Anybody have any questions about what we just did there? Okay. Okay, so the next one is this one. So, Morgan. So what, if I add this angle plus this angle plus that angle, what do they add up to? Yeah, but yeah, the answer is 180. Okay, so you were getting ahead of yourself. So this angle plus that angle, so 15 degrees plus A plus 38 degrees equals 180 degrees, because they're supplementary because you've got a straight line and you've got these angles that are breaking it up. So you can solve for A. A is going, this is what you were saying, I think, is that you subtract the sum of those two from 180 degrees, which is, I brought my calculators here today, so I shouldn't need a calculator, but I'm being lazy today. So what do you get? We get 127 degrees. So that's the answer for the second part. Okay. The third one. These two are equal to each other. So let's, when you have all these lines intersecting, even though it's more than two lines, you should be able to see that there are angles that are opposite each other. So I'm going to show you which ones are opposite, and hopefully you can see this. And I'm going to draw a line connecting these two angles are opposite each other. These two angles are opposite each other. These two angles are opposite each other. And those two angles are opposite each other. So if you have more than two lines intersecting, you still have vertical angles, and the vertical angles are still equal to each other. So let's remove those lines and just look through this thing. So where are we now? Laramie. So do you see what this angle would be based on what I just said? 70. Yeah. So this one's 70 degrees. And this one is Harmony. What is B? 40 degrees, yeah. So we've got those. Now, if we could figure out what these angles are, then we'd know what A and C were. So the question is, does anybody see how we might figure that out? Yeah, James. Right, so let's just call it X. So we'll say that the value of these unknown angles here are X. So what James said was 40 degrees plus 70 degrees plus X equals 180 degrees. Because here we have a straight line. We have four angles that make up that 180 degrees. So by doing that, we can then combine like terms. We can subtract 110 from both sides, and then we can divide by 2, so we get X is 35 degrees. So this is 35, and this is 35. As a consequence, since these two angles are opposite each other, this one's 35, and this one's 35. And if we add these numbers just to check ourselves, if we add these together, we should get 180. So 35 plus 35 is 70, 70 plus 70 is 140, plus 40 is 180. So it does work out correctly. So those are the unknown angles of that one. Anybody have any questions? Yes?
Sorry, if we're taking a test and forgot the whole thing to make it a degree, are you going to take up any points?
Probably not. Yeah, because I forget it sometimes. What's good for me is good for you guys. Okay, so here we have this one. We're going to use complementary angles. So this, between this line and that line here, is 90 degrees. And of course this vertical and the horizontal line are 90 degrees apart. So where are we now? We got to, oh yeah, Harley. So what is A? 20, yes, because 70 plus A has to be equal to 90. Now this is a right angle between these two. So if this one is 20, Jackson, what's that? 70, yeah. And then we've also got a right angle between these two. So Justin, if this is 90, this angle is 70, what's that one? The angle between this line is 90. This one's 70, so this one has to be 90 minus 70, which is, yeah, well, this plus that has to equal 90 degrees. So if this angle is going to be 90 minus 70, 20. And then here we have another right angle. So let's see who we got, Mary. So if this is a right angle, this one's 20, then that one is 70. And then finally, the one that doesn't involve 90 degrees is this one. So Miranda, this is 70. What is E? Yeah, 110, because we have a straight line, which is 180. Subtract 70, we get 110. So that's that one. Oh, that one has all the answers in it. Better erase it. Okay, let's see what we got here. So we don't want to start here because we've got three angles. We've got this angle, and that angle. Well, we could actually do that, couldn't we? Let's start up here anyway. Okay, so we're back over to James here. What is E? Yep, because these are two lines. These are vertical angles. They're both big. Okay, this angle here, which is going to be the same as that angle there, is, you can tell me what you would do, the math, and I'll do it on my calculator. So this is a straight line, these two angles. Yep, which is 48 degrees. So this is 48 degrees. Okay, let's see what else we've got. That's 90 degrees, right? So this has to be, Larry, what does B have to be? This is a right angle. 90, yep. So A also, I'll just stick with Laramie. So A has to be 90. You know, they're all 90. So this is 90. So we can actually now calculate C. We don't even need this, but we'll check it. We'll use it later to check it out. Because actually this plus that equals 180. But let's do it by the sum of the angles inside of a triangle. So where are we? Harmony. So how would I calculate C? Yeah, which is, so what we do is we add 48 and 90, which is 138. And that is equal to 42. So this is 42. And you can see 42 plus 138 is 180. Works out good. Also, if we take this angle, which is the exterior angle associated with this triangle, should equal the sum of the two interior angles. So these are the two interior angles, opposite interior angles. So 90 plus 42 equals 132. So there's a couple of ways you can check to make sure. And of course, this angle is 180. This one's 90. Okay. Moving on. Good, I guess erase all those things again now. Okay. So here we have a bunch of vertical angles. So let's see. Harley, it's your turn, I think. What is angle C? 25. And if this is 100, then this one is, they didn't ask us for it, but what is this number? It's 100, yeah. Now, here we have a straight line with three angles making up this straight angle. So, who are we at to next? Mary. So what is angle B? Okay. So this plus that has to equal, yeah, so it's 180 minus the sum of the other two. So that's 180 minus 125, which is 55. So this angle here is 55 degrees. Now over here, to figure out A, if this is 110, then Justin, so these two angles, because we have a straight line, have to add up to 180. So 110 plus what equals 180? Yep, 70 degrees. And we're done. We could figure out what this angle is. They don't ask us what that is, but that would be 70 plus 55. Subtract that from 180. So 180 minus the sum of the other two angles, which would be 55. So this one's 55 degrees. It's a coincidence these two are the same. And the other angle, let's go ahead and, this also is 55 degrees. So that gives us pretty much all the angles that are involved. Oh, did it again here. Left all my answers in. Okay, this one's easy. This is the old big. We have two parallel lines. That's what these things mean. They're parallel. So, Jackson, are you the next person, the next victim? I'm going to let you answer all the questions here. Yeah, all the small angles are 54. And all the big angles are so think, if you're doing it in your head, what number do you have to add to 54 to get 80? So you go 64, 74, and then 6 more. So that would be 26. Right? So 26 plus 100 will give you 126. That's how I would do it. Instead of trying to subtract 54 from 180, what I did was I said, okay, 54, 64, 74, 80. So that's 180 plus another 100. That gives me 126. So instead of a subtraction problem, make it into an addition problem, which I can do easier than that. So, what's that?
I'll round the 60, and then I do 60 to 140 plus the 80, which is 120, and you get the 6 plus 6.
Oh, that's good. Yeah. Yeah, I mean, that's, we'll talk about this probably in the second semester, about, well, maybe it might be later in this semester, about the whole Common Core way of teaching math. And you've seen stuff on Facebook about how crazy it is, and I used to think it was kind of crazy until I thought about how I did my mental math, and the way I do my mental math turns out to be closer to how they teach it in the Common Core. So that's what they're trying to do, is for you to think differently. So anyway, we'll talk more about that at some time. Yeah, well, that's probably what they do, something like that. Yes, speaking about that, so I read this article. It was talking about the differences between the educational system here, high school versus high school in places that score better than we do. And one thing they do is they give the teachers more time to plan and collaborate with each other and less in-class time. And I did my brief penitence teaching high school, and it was over in Rockbridge County High School, and so you had 7 periods, and you had 2 planning periods and 5 periods you had to teach at. And for the math department, the planning period was always the last period, which was good because that made it so you didn't have to stick around as long. But I just remember the planning period that I had between classes, I just kind of sat there like, I need to relax. My brain is fried. And they're just not, even at a community college, where I'm teaching 15.5 credit hours, whereas a classroom teacher is teaching a lot more than that, a high school teacher. And even now, as people who come by my office know, Justin came by, we were talking about, and Morgan, I'm already getting lost with all the stuff that I'm not keeping up with. And so the problem with doing that, of course, is giving the teachers more time during the day, is that you have to hire more teachers. So that costs money, and we don't want to spend the money. No, that's the problem with that philosophy. You also need more teachers, which we may not have. What happens is, apparently, if you look at other countries, the teachers spend about the same amount of time overall. So it doesn't mean because the teachers in America have less time during the day that they spend more time at night, because they're just trying to recuperate for the next day. It's just that they have more time to plan and grade tests and decide what the heck they're going to do, instead of just throwing stuff together so quick they have no idea what's going on. So it's just distributing the workload differently so that you have time to actually think. Okay, anyway, here we go. So we're only given one angle in this particular problem. We are given that these two are equal to each other. So we do have the fact that these two lines are parallel. So when you have two parallel lines, you typically look for a transversal and try to find the corresponding angles, the angles that should be the same value as this. And again, you kind of almost have to ignore this line for a while, which I put in there. So we just kind of ignore this particular part. And so this is a small angle associated with these two parallel lines. And so this angle and this angle are corresponding angles, and therefore they are equal to each other. So this one is 54 degrees. So that helps. Now, what does this symbol here and this symbol represent? So I'm going to ask Laramie. They're equal to each other. So as a consequence, this angle is 54 degrees. Therefore, you should be able to then, so I'm going to ask Harmony. So if these two are both 54 degrees and this has to add up to 180, what is that value? 72. Yes, because 180 minus 108 is 72. And here we have a straight line and two angles. So these two angles that have to add up to be Harley, this angle and this angle. 180. So this one has to be, yeah, it's fine. You can get your calculator in. 126. So those are the unknown angles there. Okay, into the back. Okay, erase all these again. So these two arrows mean, or these two markings mean these two are parallel. And these two markings mean these two are parallel. So let's see if we can work around through here. So again, you have to ignore certain stuff. Just concentrate on two parallel lines in this particular transversal. So there. If this is 65 degrees, then this angle is 65 degrees. Actually, no, it's not. This is a small angle. This is a big angle. So it's got to be the supplement of that angle. I almost thought the same thing, so don't feel bad about it. So 115. Yeah. So this one's 115. And I caught myself because I saw it was a big angle. So I was just doing the big, small, small, small. So, you know, all these angles, every other angle we should know. But let's go ahead and write them in. So this is 115. This is 65. This is 115. This is 115. This is 65. This is 65. So all the small angles are 65. All the big angles are 115. Okay, now we move where we have this line. This is the transversal. These are the two parallel lines. So this is a small angle. So as a consequence, Justin, if this is the small angle associated with these two parallel lines and the transversal, what angle should that be? Looking at this one, which is this, what is the small angle? 65 or 115?
You say 65 or 150?
Yeah, or. Yeah, it's a multiple choice. Is that a small angle or a big angle? Yeah, that's good. So the smaller of these two is 65, right? So 65. Okay, so that's 65. And therefore we know all the other ones, 115, 115, 65. So now we move around to this side, which actually you probably could go this way or you can go just keep going around clockwise. So again, we're comparing these two parallel lines with this transversal. So as a consequence, C is going to be, who do we have here? Miranda. This angle, pardon me? Yes. Yeah, 115. This one is, I'm going to ask you, 65. Yeah, so 115, all the small angles are 65, all the large angles are 115. And you can see we have created a parallelogram, and you can see the opposite angles in the parallelogram are the same in both directions. Okay, this one gets a little more complicated, so erase all this stuff. Okay, where to start? Does anybody have any idea? Jackson, I mean, I passed you over. So where do you think we ought to start in this thing? Where are we at? Right here? Oh, F. Oh, okay. Okay, so what is F equal to? Oh, this one over here. Oh, I see what you're doing. Okay, yep. So here we have the three intersecting lines, and you kind of went. So what Jackson did was he saw these three had to add up to 180. So this angle here is going to be equal to 180 minus the sum of the other two. Is that what you did? Yep, okay. 180 minus 44 plus 78 is 58 degrees. And since that angle is opposite this angle, this one's 58 degrees. And the thing, and I almost did it, thank goodness Jackson got it straight here, is I looked at these and you might say, oh, they're parallel to each other, but they aren't. These two are parallel to each other, but not these two. So you almost said, oh, that might be 64 because these are parallel, but you can't assume they're parallel just because they sort of look parallel. And now that I look at it, they're obviously not parallel, but I started to make that mistake. Okay, so James, how would I figure out what angle E is? So here's a straight line. Here's a right angle. Yeah. So this angle here is going to be 180 minus, so these three add up to 180, so it's going to be 180 minus the sum of the two remaining angles, which is 180 minus 154, which is 26. 26 degrees. Now they don't ask us what this is, but we could figure out what this angle is because this plus that have to be equal to 180. Okay, well, let's moving on here. Let's see what else we got. How about this angle right here? Angle A. So what we would do is you've got a line here. These two lines are parallel. Can I find an angle up here that corresponds to this angle down here? So here's the transversal, and here's the parallel line. Exactly. So this angle here corresponds to this angle right there. So those two angles are the same. And therefore, the angle A is going to be 58 degrees plus 78 degrees, which is 146 degrees. So that's 146. So as a consequence, Laramie, B is equal to so this one's 34 degrees. Okay, so we got two left over here. So again, these two lines are parallel to each other. So where are we here? I guess harmony. Okay, did I skip over you? Did I skip over you? I might have. Yeah.
Well, I'm going to put it.
Oh yeah, you did, right? Yeah. Okay. So harmony. So do you see the corresponding angle? What angle here corresponds with angle C up here? Yep, you're right. I was thinking it was. I was looking at the wrong one, but you're right. Yep. So what you've got is this parallel line and this transversal. So this angle corresponds to that angle. And therefore, this angle is just 58 degrees. And as a I'm going to let Harmony finish it off here. As a consequence, D is going to be 120. What's that?
I thought for A you would add 58 and 44.
Oh, why did I get 78? You're right. Yeah, this one's wrong too, so let's fix that. Yeah, it didn't look to scale. You're right. It's always those cases where it didn't look right, And I'm thinking, they didn't draw that very well. I should have realized, no, I just did something wrong, so let's fix that. Yeah, thank you for that. Okay, so it's 102 degrees. That looks more like 102 degrees. So that's 102 degrees, and therefore this one is 78 degrees. Yeah. Oh, and that, there you go. Okay, and that has to equal 78. So there's more than one way of sometimes doing this. I think this one's correct. So this one's 58, and these two are supplementary, so they have to add up to 122. Okay, so we're going to stop there with that one. I'm not stopping class. Don't get too excited. We're going to move to the other handout now. Yeah. So that's this one. So we're going to kind of put all this stuff together that we've talked about. So we're going to fill in all the unknown angles. So let's see, where were we? I think Harley's next here. So, so I'm going to let you. So, what does this mean? They're parallel. My cursor's acting weird here. It's like it's drunk. Okay, I think it's finally found itself there. Okay. So let's go ahead and fill in. We can fill in all of these angles. Hold on just a second. I'm making some MP4 files here. I'm going to stop those in case it's just overloading the computer here and slowing me down. Yeah, it's still kind of drunk. Oh well, hopefully I can. Yeah, it's not going to be easy. This thing is. Let me just try something here for a second. Let me see if it's still kind of drunk, or if it's that particular worksheet. Let's try opening it up again. Hopefully it won't go crazy this time. Huh? Weird. Okay. Let me put it on one page. Is that going to help me anything? No, still not. It's not obeying me at all. See, I'm not even touching it there. It was moving up and down. What else have I got going here? He didn't answer my email either. Okay, let me close this and see if I can get my drunk little symbol here. Okay, let's try it now. Nope, still being weird. Let me, I might just have to type them in because I can't, it won't let me use the cursor. So I'm going to do that. Okay. So is Harley still here? And left me. Okay, so what was that small angle? 42. Okay, good. Okay, the other two, 138. Okay, so what are these angles up here? These four angles. Yes. Yeah, I'm going to keep going with you until you make a mistake. You're like, why are you picking on me? 42, 138, 138, 42. What's that? Yeah, let me put it on one page. So those are all the angles so far. Let's go down. So I'll switch to somebody new now. Who's next here? Mary, you can help me out. Okay. Let's do these these 4 angles, we should be able to match with those 4 angles. So let's start down here. This small angle here is 52. And let me just copy that. So copy, so this is 52. So we'll move up here and we'll go Control V. So that one's 52. And that one is 52. And what, we're going to still stick with Mary. So let's, so this angle here is 128. Sounds like a good answer. Because, why is that 120? Yeah, those two add up to 180. So those are there's a supplementary. And therefore, these angles are 128. Like that, okay. So we got those 4 angles. Now here we have, so we can do the same thing here. We have these 2 parallel lines and this transversal. So Jackson's going to help me out. The Jackson is still with us. So this angle here is 112. So let's go ahead and figure out some angles up here are 112. So which one of the angles? That one right there, yep. So this one's going to be 112. What about these angles here? Yeah, so what's going to happen is this one's 90, and the sum of these two have to be 112. So this one has to be 90 minus, or 112 minus 90. So that is, the small angle is 22, and I'll put it there in a second after I enter it. So this angle here has to be 22 because this plus that equals that. So that's 90. Okay. Is that right, or 32? Is it 22? Yeah, you're right. Yeah. Okay. So now we're going to move to Justin. So let me, so these two well, let's say these 2 angles right here. So if this angle is 112, what is this angle right there?
Can I get the multiple choice again?
No. Tell me how to calculate this angle. So this angle plus that angle is equal to, are they equal to each other? Or is this angle equal to that angle? I'll give you multiple choice, a true false question. So is this angle equal to that angle? Well, this one's big and this one's small, so they can't, false, okay. So they're not equal to each other. And this is a straight line, so if things are not equal to each other, they have to add up to 180, right? Okay. So this number plus that number has to be 180. So what is that number? Use your calculator. Do you have a calculator? 180 minus 112. This angle here is 68 degrees. So this is the small angle. So we should be able to find that angle somewhere up here because these are 2 parallel lines with the transversal. So let me copy that. Control C, Control V, Control V. So this angle, 68, has to be that one, and also that angle right there. And also one more has to be that angle. Okay, so that's just from parallel lines with the transversal. I guess we didn't get this. Let me copy this one too. So this is 128 degrees also right down there because these are vertical angles. So let's continue on up here. What is this unknown angle here? What rule would we use to find that? So Miranda. Yeah, so the sum of these three angles has to be equal to 180. So what we'll do is we'll take 180 and subtract the sum of the other two angles. So 180 minus the sum of 68 and 52 is 60 degrees. That's what I got. So let's write that in there. So 60 degrees. Okay. So this angle is 60. So I'm going to stick with Miranda here. If this angle is 60 degrees, what is that angle there? Yep. So that's 60. We'll have one more with you. So if these are both 60, what do these two angles have to be? 120, because these are supplementary angles. So let's write in. So we write in 120. 120. So that goes there. And there. And if we did everything correctly, these three added together should be 180, which they are. Now we move up to this triangle. So, James, what is this angle? You can tell me the math to do. 180 minus 94, or the sum of 42 and 52. So this angle is 180 minus these two, which is 86 degrees. 86. So this angle is 86. So we can find these two angles because this angle and this angle are both supplementary to that angle. So Morgan, what is the value of this angle right there? Not Morgan. Yeah, Morgan. So this is 86. This angle has to be 94. Is that right? 180 minus, yep. So that's 94. And so is the angle that's opposite it, because they're vertical angles. So that one's 94. So Laramie. So this angle and the sum of these two angles are opposite each other. So if this is 86, then the sum of these two has to be 86. And therefore, this angle, the unknown angle, is so this. Let me go. This angle is the same as this angle. So 40 plus what equals 86? Should be 46. 46. So that one's 46. 94 plus 46 plus 40 is 180. Same way with the other way. Is that it? We got them all? I think we do. Okay. So if you struggle with some of those, what I would just suggest is you just go back and watch the recording and see how we got those. Let's kind of review how we did this. So we started here. These were vertical angles, so they were the same. These are supplementary angles, so they add up to 180. These four angles correspond to these four angles. So since the small angles were 42, all the small angles were 42, and all the big angles were 138. Then we came down here. We said 52 and this angle are vertical angles, so they're the same. These two angles are supplementary, so we subtracted 52 from 180 to get 128. These two angles are vertical angles, so they're the same. This angle and that angle are vertical angles, so they're the same. These two angles are supplementary, so this one was 180 minus 112. And then I can go up here and do all these corresponding angles. So this is two parallel lines. Here's the transversal. So all these angles equaled all those angles. And all of these angles equaled all of those. So the sum of these two had to be the same as that angle. So we took 112, subtracted 90. We got 22. This angle was unknown, but the sum of these three angles had to equal 180. So that's how we found that one. We took 180, subtracted these two. That left us with 60. These two angles are vertical angles, so they're both 60. These angles are supplementary, so you take 180 minus 60, you get 120. And so we get all those determined. Up here we knew these two, so we could subtract those from 180 to get 86. These two are supplementary, so we subtracted 180 or 86 from 180, we got 94. These are vertical angles, so they're equal to each other. This angle here and this angle here are vertical angles. So I knew the sum of these two had to be equal to that angle. Therefore, 40 plus the unknown angle had to be 86. So 46 is the number. So that's how we went through it. I'll put one of these on the test that's very similar to it, but you have to go through the, and I have another review. So as part of the review, I go through an entirely different one, and then I give you a third one that's on the test. So. So let me save that. Save as 2016, Monday, Wednesday. So I think most everybody seemed like you guys are getting it, hopefully. So we're going to move on to section 2 now, or 3. We already did section 2. Section 3. So it's the geometry of triangles. Beyond what we talked about. So far we said the triangles, the sum of the angles of a triangle add up to 180 degrees. The exterior angle is equal to the sum of the opposite two interior angles. And we're going to talk about congruent triangles, similar triangles, and about the Pythagorean theorem. So here's an example of two congruent triangles, a blue triangle and a red triangle. And you can't just say they look about the same. You have to have some way of showing that everything is the same, because congruent means equal. And to be equal, the length of all three sides have to be the same, and all the corresponding angles have to be the same. So in this particular case, it's shown by these markings. So let me zoom back in a little bit now that we've finished our triangle. So you can see this side is equal to that side. This side is equal to that side. This side is equal to that side. And all the angles are the same. Now if you looked at this triangle, you might think, if I said, is this triangle congruent to those triangles, you might say, well, no, because they don't look the same. These look the same because not only are they all equal to each other, the sides, but they're also aligned in the same direction. But if I took this and I flipped it from left to right, I would get that, and I could then fit it in there, and I would see that they're congruent. Now, if I originally showed that, this had 3 markings, and this had 2 markings, and this had 1 marking, and this had 2 little arcs, and this had 1 arc, and this had 3 arcs, then I wouldn't have had to rotate it, flip it, to be able to determine that they're congruent to each other. But so you have to be a little careful. Don't assume because they look the same that they are congruent. And also, just because they're not aligned in the same direction doesn't mean they're not congruent. The important thing is that all the lengths of the sides are equal to each other, and the angles are equal to each other. So that's what congruent means. Now, it turns out you don't have to say everything's equal to each other to be able to imply that triangles are congruent. You spend a lot of time in geometry proving all these things. We're not going to prove them, we're just going to review them. So in your book, you'll see that there are 3 cases which allow you to say that triangles are congruent without saying everything's equal to each other. So we'll look at each one of these. So there's the side angle side, which says if 2 sides in the included angle of one triangle are equal respectively to 2 sides in the included angle of the second triangle, then the triangles are congruent. So as a consequence, because if 2 sides in the included angle are equal to each other, all the other sides, the third side is equal to the corresponding triangle and the 2 angles are the same. And you can prove that by using geometric theorems, which we're not going to do. Likewise, if you specify 2 angles and the included side, there's only one way that that can work out. There's a unique triangle when you specify the 2 angles and the included side. That's called angle side angle. And also if you specify all 3 lengths of the sides of the triangle and those side lengths are the same, then all the angles have to be the same and they are congruent. So those are the ones that work. So you might, you know, the usual thing that people do is they say, well, if side angle side works, shouldn't side side angle, or shouldn't angle angle side, you know, the other combinations of A's and S's. So of course, you know, you've got the one we can't use just because it is rude. But that, besides being rude, it doesn't work either. Or the other way, you could do SSA and then you wouldn't be quite as rude. It's the same thing. Okay. So the reason that doesn't work is that there are multiple solutions. There are probably 2 triangles that can have those combinations, the other combinations, the ones that don't work. This is just to show that if you have 2 side lengths and an angle, which is this one, the included angle, that there's only 1/3 side that can fit in there, which there's a certain length, and then that length defines the angles. So that's why the angle side works. The other one is the angle side. The way that works is you have a side length and you have 2 angles, and those 2 lines projected intersect at a unique point. And as a consequence, there's only one way to result in one triangle. I just want to demonstrate the other case. So here if you had angle side, so that is 2 angles. So here's 2 angles. Here's one angle. Here's another angle. Here's the length of the side. There is more than one way this thing can be arranged. And I'm going to think about this so I can show you next time, because I haven't thought about this since last year. But I'll demonstrate that there is more than one solution if you do that. This is an angle because you've got the angle and you have the lengths unspecified. Likewise, this is also just an angle. This is one of the sides. So those are the 3 things, and you should be able to put them together and show that there actually are 2 ways you can put it together, 2 triangles. But right now I can't think of it, and it's already an hour and 14 minutes into the class. So we'll see you on Wednesday.